Welcome back. In the last video, we implemented gradient descent, which in every iteration minimizes the error and adjusts a linear model that better classifies our data until it comes up with the perfect line. Thinking in terms of a perceptron, this linear model with some equation can now receive new unlabeled inputs and output the probability of the point being in the positive region. This is known as feed-forward, the process neural networks use to turn input into an output. And this perceptron is the most basic form of a neural network. Really, all of this ties back into the concept of supervised learning, since in our code we started with a data set, where each point in our data is defined by a label. Every point in the top region was labeled 0, every point in the bottom was labeled 1, and we used this labeled data to train our network to come up with the best linear model that classifies them. That way, when we receive newly input data that are unlabeled, using our model, we're able to make a prediction that properly classifies it, obtaining an output. This is the simplest type of feed-forward. But to end our discussion on perceptrons, let's talk briefly about backpropagation. This is a term you're going to hear quite often in this course, even though we've already implemented it in our code. When training our neural network, initially it starts with a random line, which more often than not will misclassify all of our training data. Backpropagation is something which was implemented when we wrote the code for gradient descent. When there are misclassified points, the error function will result in a large value, and so it keeps updating the weights as well as the bias value to then obtain a linear model that best classifies the data. That is really it for backpropagation. We'll see more complex implementations of it once we deal with multi-layered neural networks, but for now, this concludes our discussion on the most basic form of a neural network, the single perceptron.